Okay, we're at the end. Review questions. Still section 1, theory of heat. Still unit 2, matter and energy. Page 38, comparison period. The examples we use to illustrate this will not take efficiencies for the various fuels into account. Efficiencies of fossil fuels will be discussed in the corresponding units of this text. Some examples of conversions follow. 1. Converting electric heat rated in kilowatts, kW, to the equivalent gas or oil heat rated in BTUH. Suppose that we want to know the capacity in BTUH for a 20 kilowatt electric heater. A kilowatt is 1,000 watts. 1 kilowatt equals 3,413 BTUH. 20 kilowatts times 3,413 BTU times over kilowatt hours equals 68,260 BTUs per hour of heat energy. 2. Converting BTUs per hour to kilowatts. Suppose that a gas or oil furnace has an output capacity of 100,000 BTUs per hour. Since 3,413 BTUs per hour equals 1 kilowatt, we have 100,000 BTUs per hour divided by 3,413 BTUs per hour per kilowatt equals 29.3 kilowatts. In other words, a 29.3 kilowatt electric heating system would be required to replace 100,000 BTUs per hour for furnace. Replace the 100,000 BTUs per hour furnace. Safety precaution. Any device that consumes power, such as an electric motor or gas furnace, is potentially dangerous. These devices should only be handled or adjusted by experienced people. Well, the only way to get experienced is by kind of just going at it, you know. Okay, review questions. 1. Matter is a substance that occupies space and has, and it says color, texture, temperature, mass. We all know that one. 2. Solid, liquid, and gas are the most common. A, states of matter. B, specific volume. C, okay, we already know it's A, states of matter. Question 3. In what direction does a solid exert force? Does it exert it upward, or outward, or downward? Downward. In what direction does a liquid exert force? It's either outward or upward or downward and outward. Let you guess on that one. Question 5. Vapor exerts pressure in which direction? Could it be D, outward, upward, and downward? Question 6. The weight per unit volume of a substance is defined as... It's either A, mass, B, density, C, work, or D, specific gravity. The weight per unit volume of a substance is defined as... That's tricky. This is not easy stuff, but... Okay, question 7. The density of a substance compared to the density of water is known as... It's either specific gravity or specific volume or mass or weight. Question 8. The volume occupied by 1 pound of a fluid is known as... The volume occupied by... I think it's specific volume. It's either specific volume, specific gravity, mass, or weight. The density of tungsten is 1,210 pounds per cubic foot. What would be its specific volume? The interesting thing in the answers is for some of the answers it says cubic feet per pound, and then the other one it says pound per cubic foot. I'm trying to trick you. Yeah, I'm gonna have to come back to that one. 10. The specific volume of red brass is 0.001865 cubic feet per pound. What would be its density? Again, they're switching around the units at the end. Pounds per cubic foot, and then they have one option, it's cubic feet per pound. Aluminum has a density of 171 pounds per cubic foot. What would be its specific gravity? Got some answers like 2.74 is A, D is 47.2. Question 12. 4 pounds of a gas occupy 10 cubic feet. What would be its density and specific gravity? Then we got like 0.4 cubic feet per pound, 0.4 pounds per cubic foot, 4 pounds per cubic foot, 4 cubic feet per pound. Tricky. Whose law states that the volume of a gas varies inversely with the absolute pressure as long as the temperature remains constant? It's either A, Charles, B, Boyle's, C, Newton's, or D, Dalton's. Question 14. At a constant pressure, how does a volume of gas vary with respect to the absolute temperature? At a constant pressure, how does a volume of gas vary with respect to the absolute temperature? Either it might be A, it will expand when it is heated or cooled, or B, it will remain constant, or C, it will expand when cooled or contract when heated. Okay, it's not that one. It will expand when heated or contract when cooled. I think it's D. 15. Whose law states that the total pressure of a confined mixture of gases is the sum of the pressures of each of the gases in the mixture? It's either A, Charles, B, Boyle's, C. It's not Newton. Newton, that's like, we didn't even talk about Newton. Or D, Dalton's. 16. What are 2 types of energy most frequently used or considered in this industry? Is it solar and fossil fuels, or nuclear and wind, or nuclear and soil, or solar, or wind and solar? 17. The time rate of doing work is called, it's either weight, distance, power, or force. 18. Force times distance is used to determine either weight, work, power, or volume. If an air conditioning compressor weighing 300 pounds had to be lifted 4 feet to be mounted on a base, how much work in foot-pounds must be done? Was it 12,000 pounds per cubic foot, or 12,000 cubic feet per pound, or 120 foot-pounds, or 1,200 foot-pounds? How many watts of electrical energy are equal to 1 horsepower? This is question 20. It's either 1,492, or 746, or 74.6, or 373. How many watts of electrical energy are equal? What unit of energy does the power company charge the consumer for? We already know it's kilowatt hour. 22. If 3,000 cubic feet of air is crossing an evaporator coil and is cooled from 75 degrees Fahrenheit to 55 degrees Fahrenheit, what would be the volume of air in cubic feet exiting the evaporator coil? Okay, math. 23. A gas is compressed inside a compressor cylinder. When the piston is at its bottom dead center, the gas is initially at 10 psig, 65 degrees Fahrenheit, and 10.5 inches cubed. After compression, and when the piston is at top dead center, the gas is 180 degrees Fahrenheit and occupies 1.5 inches cubed. What would be the new pressure of the gas in psig? 24. How many BTUs per hour would be produced in a 10 kilowatt electric heater? A is like 4,095 BTUs per hour, or D is 495 BTUs per hour. 25. How many BTU of heat can be produced by 4 kilowatt hours of electricity? Is it 136,520 BTUs per hour? Or is it 13,652 BTUs per hour? Or is it these other two answers? I don't know. Okay, question 26. What does an object weigh, or why does an object weigh less on the moon than on Earth? It's less mass, so there's less gravity. 27. Why is information regarding the specific volume of gases important to the designer of air conditioning, heating, and refrigeration equipment? 28. Describe horsepower and list 3 quantities needed to determine horsepower. 29. Explain how specific volume and density are related to each other. 30. State the law of conservation of energy and explain its importance with regards to accounting for energy. 31. Explain how heat energy flows between a substance at minus 125 degrees Fahrenheit and a substance at minus 175 degrees Fahrenheit. 32. This is the last question. Explain how magnetism can be used to help convert electrical energy to mechanical energy. Okay, that was fun. That was page 38 and 39. See you guys tomorrow.